And welcome, students, as we dive into our next lesson on Boolean expressions as we talk about short circuit and complete evaluation. So, getting started. Recall from our last lesson the concept of truth tables. We looked at once for and, or, and not. Now, Java will occasionally utilize shortcuts when evaluating Boolean expressions. This is because sometimes you only need to evaluate part of the expression in order to determine the Boolean value. So this is what's known as short circuit evaluation. So let's look at an example. Savings is greater than or equal to 0, and depends is greater than 1. If savings is negative, then that part of the expression is false. Now, according to our truth tables from the previous lesson, if we have an and expression and one of the two parts is false, then the whole expression is false. In this case, Java looks and sees that one part of the and expression is false, so rather than having to waste time and memory and resources evaluating the second part, it just simply skips it and just automatically determines the value. Because remember, with an and, if one part is false, the whole expression is false. So Java is like, I don't need to worry about the second part because I already know it's false. So when we start evaluating these and ors, Java will shortcut an and expression if part of the statement is false. Java will shortcut an or expression if part of the statement is true. Because remember, with an or, the only time it's false is if both are false. So I say, hey, I see it's a true. Why should I have to worry about the other half? Because I already know it's true. And here's another example. If kids is not equal to 0 and pieces per kids is greater than 2, or equal to, says an output line, each child may have 2 pieces. In this example, if the number of kids is 0, then the first evaluated expression would be false, and the Java could short circuit the rest of the expression to be false. Additionally, in this example, this also prevents a runtime error of dividing by 0, because if you look at the other side, we have pieces divided by kids. So if you have 0 kids, you'd be dividing by 0, which would crash your program. So by short circuit evaluation, Java can look at this and say, hey, I don't have to worry about that other side simply because I already know the first side is false. All right, now let's discuss, that's a short circuit, but what about a complete evaluation? Well, we can technically ask Java to run a complete evaluation, which the program evaluates the expressions first and then checks the truth table. However, for our purposes, we're always going to use the and or in order to obtain short circuit evaluation, as it can help us avoid issues like runtime errors like we saw on the previous slide where we had the potential divide by 0 error. All right, and that's it, folks. There's nothing really complicated about it. It's just another quick and easy lesson. So I will see you next time.